Hey everyone, welcome back. In this video, we are going to do a quick review of piecewise functions for your AP Calculus course. First of all, let's talk about what a piecewise function is. All it is a set of multiple functions that are only defined for certain input values. I know that sounds kind of confusing, so let's take a look at an example because I think that's the best way to understand this concept. So let's look at f of x here down at the bottom. So what do we notice? First of all, we notice we have two function rules. We have this top function, which is just adding 1 to whatever we input for x, right? And then we have this bottom function, which is just doing 5 minus our input value and returning that value. So we also notice that over here on the right side, this is telling us when to use each function rule. So for our top one, we're using it for 0 to 3 inclusive, and then for our bottom one, we're using it from 3 to 5, only including 5. So let's just take a quick example. Let's just say we want to define f of 1. So first thing I'm doing with piecewise function is I'm looking over here because this is going to tell me which function rule to use. Since my x value, my x is equal to 1, right? So since it's between 0 and 3, I'm going to be using my top function rule. So if f of 1 is equal to x plus 1 when x is equal to 1, I'm simply going to do f of 1 equals 1 plus 1, which equals 2, right? So not too crazy, right? Pretty straightforward. Let's take a look at another quick example. If I did f of 2, I would be using the same function rule because again, my input value is still between 0 and 3. So now I would simply do 2 plus 1 and I would get 3. Now let's take a look at something like f of 4. Now my x value of 4 is in between 3 and 5, so I'm going to use my second function rule. So here I'm going to be using this, which is 5 minus x. So now I'm going to do 5 minus 4, which would give me 1. So now last thing to kind of review is just these boundary points. These are always going to be important. So you do need to remember what this means. So this means less than or equal to. This just means less than. So if I were to do f of 3 as my final example, I would be using this top function rule because this is still defined when x is equal to 3, right? It's defined for x is less than or equal to 3. So I would still use my top function rule. I would plug in 3 for x, and then I would get 4. Okay, great. Let's take a look at a graph of this function to put it all together. All right, so you can see here in blue, this is just the top function rule. So this is just x plus 1. And then you can see here in red, this is the bottom function rule. This is 5 minus x. Basically, how I teach my students to graph piecewise functions is to literally just graph the entire function. So as a really quick example, if our top function rule is y equals x plus 1, I would just think of this as y equals mx plus b. My y-intercept is 1, my slope is 1, so I would just draw a line there. And then how I teach my students to do this is to basically literally just use their eraser to erase any values that aren't in this defined range here. So it's only defined from 0 to 3. So I would literally erase everything until I got to 0, and then I would go to 3 and I would erase anything after that, right? So it's literally just graph the function and then basically erase it for any parts that are not within this range here on the right side of the piecewise function. I would do the same exact thing for the one below. Only other thing to remember is if you have less than or equal to or greater than or equal to, you're going to fill in the circle. If you only have less than or greater than, you're going to leave the circle open. All right, moving on. Now let's talk about why piecewise functions even exist. A good example of this is the cost of a cell phone plan. Oftentimes, cell phone plan cost will change depending on how much data is used. So here we have this cost function, c of x, and it's defined here. So this is going to represent the output value or the cost. And then this over here is going to represent the gigabytes of data used. So this particular function charges $50 per month for up to 10 gigs of data. And then it charges an additional $5 for any additional usage over the 10 gigs of data. So you can see that here. This is the output value of $50 per month if our gigs are between 0 and 10. And then if you look at the second part of this, no matter what, let's say you used 15 gigs of data. No matter what, you're still going to have to pay that $50 for the first 10 gigabytes you used. So that's why this 50 is here. But then you also have to pay an additional $5 for every gig used over 10. So that's why we have to subtract there, because you can think of it as we already paid for this initial 10 gigs of data. You're only paying the $5 for the amount over that, right? So if we used 15 gigs, we would pay our initial $50, but then we would also pay $5 times the 15 minus 10 gigs, right? Or plus the 5 times the additional 5 gigs used. So it'd be 50 plus 25, which is 75. Okay, good. Let's take a peek at the graph of this function. So again, we have, I'm trying to get it all in one. There we go. Okay, good. So again, right here in blue, we have what I'll just call our first function. This is always going to output 50 for when our gigs of data are between 0 and 10. And then for anything over 10, I apologize, this should really have an arrow here. So for anything over 10, we're going to be paying, again, the $5 on the additional gigs used. So you can see now we have a slope here, right? Because now our cost is going to change depending on how many gigs of data we used. Okay, moving on to real life example number 2, let's talk about income tax brackets. Many of you will actually encounter this at some point in your life, so it's kind of interesting. So let's say this simple income tax bracket system that I came up with, let's say you pay $10,000 for the first 10, I'm sorry, I meant to say 10% of the first $10,000 you earn. Let's say you then pay 20% of any income that's between the 10 and 30,000. And then let's say you pay 30% on any income over 30,000. So this is a common misconception that if you're in the 30% tax bracket, you pay 30% of your entire income. You actually don't, at least coming at this from a US point of view, not speaking for the entire world or anything like that, just for where I live. So what happens is that you'll see it here in the function, right? So for any income between $0 and $10,000, we're just paying 10%. So that's probably the most straightforward. However, let's say you earned $20,000. In this case, you're going to have to pay the 10% of the first 10,000. Well, what is 10% of 10,000? It's just 1,000. So that's right here, right? So that's the initial value you're going to have to pay. Then you're going to have to pay the 20%, which is just the 0.2 there, times any money earned over the $10,000. So that's why you're subtracting it. Again, you can think of this as you've already paid your tax on that, so you're taking it out, and you're only paying 20% on the amount over the 10,000, of course, up to the 30,000 limit. And then I'm going to go through this last one a little quicker, but same idea here. You're going to be paying $5,000 on the first 10,000 and this here combined. Then you're going to be paying the 30% on any money over $30,000. Okay, good. Let's take a quick peek at the graph of this function. So you can see here on the y-axis, we have tax in dollars. Again, I apologize for the way this graph printed. Please note that this is 10,000 and then so on going down. All of these numbers should be multiplied by 10 to the fourth. And then on the x-axis, we have income in dollars, and same issue here. All of these numbers are multiplied by 10 to the fourth. So basically this would represent $10,000 in income. This would represent $20,000 in income, and so on. And so again, you can see here the top function rule is in blue, the middle function rule is in red, and then the green function, which should also have an arrow, is our bottom function there, which would represent the tax paid on any income over $30,000. All right, thanks so much for watching. Meet me in the next video where we're going to talk about continuity of piecewise functions.